I'm going to start today's video with a question. Do any of you have any idea what this is? I've shown this photograph to a lot of people, and I've gotten all sorts of answers, everything from an electron micrograph of a sponge to a circuit diagram from the Borg cube. But the truth is actually even more astonishing. It's a map of the fine structure of the entire universe. Most everybody knows that stars are grouped into galaxies, and that within a galaxy, the distance between one star and the next is quite large. But the distance between the galaxies themselves is even larger. Even the old Star Trek got that one right, despite their playing fast and loose with the laws of physics in just about every episode, despite Scotty's insistence that you cannot change the laws thereof. There's an episode called By Any Other Name, which is about some evil aliens from the Andromeda Galaxy who hijack the Enterprise and try and use it to take them back home. The trip, we're told, will take 300 years, and that's at warp 10, which we're also told is faster than a Federation starship can go. So the intergalactic spaces are so large that they're a bit beyond imagining. And if you want your mind further blown, realize that each of the filaments in the picture that I showed you is not made of stars, it's made of galaxies. Billions of them. In that diagram, the Milky Way and its nearest neighbor, the Andromeda Galaxy, would be almost right on top of each other. What's fascinating about this diagram, which by the way is courtesy of NASA, is not the filaments themselves, but the spaces between them. These spaces are called voids. The nearest one, the Boötes void, is centered 700 million light years from us. And these voids are ridiculously huge. They're so large that if you put the Earth at the center of the Boötes void, we wouldn't have even had telescopes powerful enough to see the nearest star until the 1960s. The night skies would be completely black. That, my friends, is a whole lot of nothing. What is most mind-bending about this whole thing, and in fact what sent me down the rabbit hole of researching it in the first place, is that scientists think that the location of these filaments represents the position of quantum fluctuations in the universe immediately after the Big Bang, when the universe itself was only a centimeter or so across. As inflation took over and the universe expanded, these anisotropies, as the astrophysicists call unevenness in the distribution of matter, became magnified until finally you have these filaments that are densely filled with matter and large gaps in between, in which there really is nothing. And eventually, you have a universe that looks a bit like a Swiss cheese made of stars. Of course, I'm using densely filled in a comparative sense. The cold wastes of interstellar space between the Sun and the nearest star, Proxima Centauri, really doesn't have much in it. Some dust, maybe a few rogue planets, but that's about it. On the other hand, that's jam-packed compared to the Boötes void, in which there are light years upon light years of space in which there is not so much as a single hydrogen atom. All of which makes me feel awfully small. Our determination to act as if what happens down here on Earth has all sorts of cosmic import becomes kind of ridiculous when you look up at the night sky. It's smashed to smithereens when you consider the structure of the entire universe. A lattice work made of threads of stars with spaces in between, filled with nothing but cold, eternal silence, and darkness so profound that there's not a single star in the sky to break it. And I don't know about you, but that makes me want to climb back under my covers and hug my teddy bear for a while. If you enjoyed this video, please give us a thumbs up. Our resources are down there, and please subscribe to our channel. Thank you.